All right, folks, Bass Action is back in action here. We are at the end of this chapter. I know it's been a long chapter, a lot going on. We're going to wrap this up with our finding the other parts of our financial formulas. Just to give you a heads up on this page, you might have some calculator troubles. If you're not sure how to work your calculator, please, please, please talk to me in class and spend your time here on this video and going through these notes, making sure that you understand the algebra to rearrange the problem and you understand how we're actually just putting things into our formulas. The calculator piece is a really easy piece for us to layer in the classroom. So don't stress about that element. Focus on the whys and the hows of what we're doing with the algebra if that calculator becomes a barrier for you. Okay, so on this first problem, we are looking for the present value. You'll notice that I did not give you the formulas here because you are expected to know these formulas. So we're going to be looking for our present value. That means we're going to be looking for the P in our formulas. So we are told in this problem that our time is going to be 10 years. We're working with $1,000, and then we're going to have two different scenarios on A and B. On A, we're going to have 8% compounded monthly. On B, we're going to have 7% compounded continuously. There's that key word for us that we're going to, tells us that we're going to use our PERT formula. So on A, the formula that I'm going to be working with, if you want, you can write it. The more you write it, the easier it is to remember it. We're going to have the P, we're going to have 1 plus R over N to the NT. On our continuously, we're going to have our A, I'm going to write an A there, sorry. On our continuously, we're going to have our A, and we're going to have our P to the RT. All right, so let's start plugging in here. It tells us that we want to have $1,000 in the end, so that's our future value. So we're going to have our $1,000. We don't know the present value. That's the point of the question. So we're going to have 1 plus, it tells us our rate is 8%. So we're going to convert that to our decimal, 0.08. We're compounding monthly, so that's going to be 12 times each year. Our exponent then is going to be our 12 times our number of years, which is 10 years. So what I can tell is that this exponent can easily clean up, but if I type this into my calculator, I'm going to get a repeating decimal. I don't really want to convert that to a decimal at this point because as soon as I cut off that decimal, it's going to change its value. But what I can recognize is that this entire amount right here could be typed in our calculator. We could just pretend, let's say it's a 5, which means we're going to divide the entire equation by that 5. So we could actually write our answer in a calculator-ready form and say the principal, or our beginning amount, is going to be our $1,000 divided by this entire expression. I'm going to clean up the exponent. So it's going to say 1 plus 0.08 over 12 raised to the 120th power. So if I were going to type this in my calculator, what I would do is I would do the 0.08 divided by the 12. I would add the 1. I would take that answer, raise it to the 120th power. Then I would let my calculator save that decimal, and I would do 1,000 divided by that answer. So you can kind of go through that if you want. Try that on your calculator. Pause at those different parts. And when you type that in, the answer that you should be getting, taking it out to cents, will be $450.52. If you can't get that, make sure to talk to me in class. We'll go through some examples in class and I'll help you through that. On our compounding continuously, again, we know that we want to end with $1,000. We don't know the principal amount. That's the point of the question. E never changes. Our rate this time is 0.07 and our time is still 10 years. So if I want to type this into my calculator, what I'm going to do is I'm going to say that my principal is going to be my $1,000 divided by E, and I can condense that exponent, make it a little bit nicer, and write it as a 0.7. So when I type that in my calculator, I'm going to get, I don't have this one worked out for us, E to the 0.7 my principal amount is going to be $496.59. So again, we get to this e value here by doing our second shift on our natural log. We've got our exponent, and I would just do the 1,000 divided by that answer. Now, on our next problem here, we are looking for our rate of interest. So we're going to find a different part of our problem. Furthermore, this one is going to be phrased slightly differently. So we want to know the annual rate of interest. It tells us that we're compounding semi-annually, so we know that that means it's going to be twice a year. Continuing on, we want to double our investment. So it doesn't even tell us how much we're starting with, but it does tell us that we're going to be working with 5 years. So this is a really good hint. If you're not sure, you'll find a pattern, but if you're ever not sure, just ponder this. Just assume you're working with $10. That's how much you're investing. So let's write our formula. Since it's compounding semi-annually, of course, the formula that we're going to be working with is our A and our P and our 1 plus R over N to the NT. And what we're going to do is we can just assume that we're going to be working with $10. So let's assume that we're investing $10. And if we want to double it, then of course we want to end with $20. Now we're going to have 1 plus our rate. We don't know our rate. That's the point of the question. We do know that it's compounded semi-annually, so I can put a 2 there. And then my exponent is going to be a 2, and my time is 5 years. So now I can just start working this algebra. I would personally divide both sides by that 10, and what I'll notice is that on the left-hand side, I get a 2. Remember, we were wanting to double, so that 2 makes sense to us. So then I'm going to have 1 plus R over 2 to the 10th power. Now, this rate is trapped inside this expression here that's raised to the 10th power. So what I'm going to do is I'm going to take the 10th root, or take it to the 1/10th power. I'm going to take the 10th root of each side of this equation, which means in my next step, what I'm going to have is 2 to the 1/10th power equals 1 plus R over 2. I can subtract my 1, so now I'm going to have 2 to the 1/10th power minus a 1 equals R over 2. Then I can multiply both sides by 2. And now I have my answer in a form that I'm ready to type into my calculator. Now, as you get kind of good with this, you don't even always have to write all the things down. So in our calculator, we have 2 times 2 to the 1/10th power minus a 1. So we can type this into our calculator. This one you can mostly type in the way you see, but I would probably do the parentheses first. I would do 2 to the 1/10th. I'd subtract my 1, and then I'd multiply that answer by 2. When I type that in my calculator, I'm going to get a decimal that looks like this. It's going to look like 0.1435. But again, as we talked earlier about rates, it's better to convert that to a nice percent. So I would write this as 14.35%. All right, last one that we're going to look at, very last example of our chapter, we're looking for time. And we've actually already looked at almost this exact same problem on the uninhibited growth page. So on this one, we want our investment to triple. And again, it doesn't tell us an amount. It tells us that we're going to have 5%, and it's going to be compounded continuously. There's that key word for us, that continuously, that means something for us. So that means that we're going to be working with our PERT formula. And if we want it to triple, if you already know what to do, you can. If you're not sure, let's just assume we're going to invest $10. So if I'm going to invest $10 and I want it to triple, I'm going to have 30 at the end. So I'm going to have E. I don't know my rate, but I do know, oh wait, no, I do know my rate on this one, sorry. I know my rate, I don't know my time. Got myself all jumbled. My rate is 0.05, and my time is what I'm trying to find. So now we can divide both sides by our 10, and we'll get a 3 on the left-hand side. Remember, we wanted it to triple, so that 3 should make sense to us. E to the 0.05t. This should look like what we did on the uninhibited growth page and all of our solving exponentials. Convert this to a logarithm. Of course, log base e is going to become natural log, and then we'll of 3 equals 0.05t. So our time is going to be our natural log of 3 divided by 0.05. So our time is going to be approximately 21.97 years, which makes sense because 5% isn't a very, very fast rate of growth. All right, so that's all we have. We're all done with this chapter. And again, any calculator issues, please just dog-ear those. Make sure you understand the algebra, getting it into the calculator ready form, and learning to enter this in the calculator is a very, very easy piece for us to layer in.